Hello everybody and welcome to your video notes on Learning Target 5.4 at the basic level. This is Mr. Basil and let's get to it. So in this video I'm going to be going over the intro to balancing chemical equations. So this is the basic level notes and here we go. So let's just start with a very basic kind of chemical reaction. So let's just say we've got hydrogen gas and we've got chlorine gas, and that reacts to make HCl. Okay, we could put our phase notation on there. Like all of these would be gases, so I could write that here. Gotta get that away. Here, here, and here. But I'm not going to do that. I'm just going to keep it very simple. And so what we've been talking about up until this point is that we can use particle diagrams to represent this. So I'm going to start with the particle diagrams first, and then eventually we're going to bridge this into a point where we don't need the particle diagrams anymore. So that would look like this. So if you know how to do the particle diagram, go ahead and try doing that on your own. But this is what you'd have. Really, those should be touching, but I think you get the idea. Okay, so as we have this drawn here, you'll notice that I have two hydrogens on the left, and I only have one on the right. I have two chlorines on the left, but I also only have one on the right. So one thing that you have to be able to notice is like if an equation is balanced or not. This would be called an unbalanced equation. Because this does not follow the law of conservation of mass. And we need our chemical reactions to, our chemical equations to actually be balanced in order to actually use them. You'll find that these are very useful things to use as we do calculations and we analyze different types of problems that we have. We need our equations to be balanced. So the way that we can do that is by adding more molecules to our system. And so you can make a little note of that over here. Okay, so if we want to do that, I need more hydrogens and chlorines, right? I've got two hydrogens on the left, and I need two on the right, and I have one currently. So what I can do is I can add another HCl molecule, so H and Cl. So now that I have these two HCl's, this equation is balanced. Yay, I did it! And yeah, two chlorines, we're good to go. And so now, what I have to do though is I have to add a coefficient. I have to add this coefficient in front of the HCl to notate that now there are two HCl's. If you're not sure about the difference between subscripts and coefficients, you should go back and watch one of the earlier videos. And so now I would want to go back in and switch this and say that this is now balanced. Okay, it's balanced if you have the same amount of atoms on the left and on the right. All right, I'm going to do 2 more examples here to help you illustrate this idea. All right, so very popular, very common chemical equation. Hydrogen gas and oxygen gas react to form water, H2O. So we can start this in a very similar way. Got my 2 H's on the left, and I have 2 H's on the right. But then I also have 2 oxygens on the left, and then I just have the 1 oxygen here. And we'll just do that. So again, 2 H's, 2 O's drawn here, and then 1 H2O. Now we can see that this is unbalanced. So I'm going to say unbalanced right now because I don't have the right amount of oxygens. So I've got 2 oxygens and only 1 oxygen. So law of conservation of mass is not being followed. Somehow I'm losing an oxygen the way I have this written, which we know isn't possible. So we have to show that in our equation here. So if I need more oxygens, I'm going to add another water molecule. You can only add more molecules of what you already have in the problem. And I think that I said that here. You can only add more molecules from the equation to balance the equation. Okay? So I'm going to add another water molecule. So let me just do this. There we go. So now I have 2 oxygens and 2 oxygens. I'm good to go there, but now I ran into a problem. I've got now 4 hydrogens and only 2 hydrogens over there. So this will happen. This will happen where you'll try to fix one thing and then that will throw something else kind of off. In which case then you got to go back to the drawing board and see what else you can do to continue on doing this. Because you do need 2 oxygens. You do need 2 water molecules to do this. So what you can do is I can take this and add another molecule of H2. Now I've got 2 H2 molecules, 1, 2, 3, 4, and then 4 total hydrogens. So 1, 2, 3, 4, and 1, 2, 3, 4. There we go. And that didn't change anything for the oxygens, so I'm good to go as well. Now, once again, if I change the number of molecules, I need to change the coefficient in front of that. So I've got 2 H2 molecules, and I have 2 water molecules, and I'm good to, all right. Now, some of you may have started this problem, and you may have thought, oh, okay, I don't need to do any of this. And instead of doing, so this is the correct answer. This is correct, and is now balanced. But I'm going to show you a way of thinking that is incorrect, and I'll explain why. Let's say instead of doing what we did, you would have just said, okay, well, what if I put a 2 there? Now I've got 2 oxygens, and I've got 2 oxygens, I've got 2 hydrogens and 2 hydrogens. Well, yeah, congratulations, it's balanced, but it's not the right thing. It's not the right way to do this because now this isn't water. This is hydrogen peroxide. If you remember, that's the equation that we use for hydrogen peroxide. And so that would actually look like this. H-O-O. Okay? Notice how this are not the same. Okay? And in fact, hydrogen peroxide is deadly. You drink water all the time, but hydrogen peroxide, that would definitely mess you up. So let's make a note of that. You can only change coefficients. I don't know if I spelled that right. Oh well, you get the idea. Coefficients to balance. Never change subscripts when balancing. Okay? Don't do it. Just don't do it. Okay? Alright, and then we got one last one to end on, and then move on to the next video. Okay, so I've got N2 plus H2 yields or makes NH3. So for this one, you know, we're going to try to avoid using the particle diagrams to do this, and I'm going to show you a different strategy, because most of the time, drawing the particle diagrams it's kind of an involved process, right? You're having to draw so many different things. You can always default back onto that, but I'm going to suggest trying to eventually not draw the particle diagrams anymore to do your problems, because you're going to be doing a number of these. And the best way to get good at this is just to practice. So I'll just have this up here, just a reference, as the bridge between doing this with and without the particle diagrams. Okay, so that's how we would have drawn it before. And yeah, so here's what we can do. What I want you to do is draw these vertical lines in between the arrows, and then list the elements that are on the left and on the right. And this is going to be a good way to compare if we have the same numbers on the left and the same numbers on the right. So here I've got 2 nitrogens, so I'm going to write a 2 there. I'm just going to zoom in just a little bit here. And I've got 2 hydrogens. That's not a 2. There we go. And on the right hand side, I've got 1 nitrogen and 3 hydrogens. Keep in mind this 3 only applies to the hydrogen. If there were parentheses around the whole thing, then yeah, then it would be 3 of everything, but that's not the case. Alright, so now it's very easy to see that this isn't matching up in either case. I've got 2 and 1 and 2 and 3. So there are a few different ways we can approach this. Over here on the right hand side, I can see that I need more nitrogens. The hydrogens aren't quite lining up here either. So you can choose whichever one you want to start with, it does not matter. But the one thing I will say, just like in balancing charges, balancing equations, if you see a 2 and a 3, you're going to try to think 6. So let's just start there, because that's something that we've worked on before. So if I see a 2 and a 3, it's hard to know what numbers they need to be. So again, we're going to try to make 6 total hydrogens on the left and 6 total hydrogens on the right. So over here, if I want to get to 6 hydrogens, what would I need to put here? Something I'm going to multiply by 2 to get to 6. And if you're thinking 3, then you are correct. So let's put a 3 here. So now this 3 tells me I have 3 total H2s. So that's going to change this to 6. Okay, that doesn't change anything about my nitrogens, it's just the hydrogens. So again, if you're having a hard time visualizing this, that's what I have. That's how I know that I have 3 hydrogens. It's 3 total H2 molecules. Now, the hydrogens on the right-hand side, I want to get those to 6 as well, because a 2 and a 3. So I'm going to put, can you think of it? Yeah, a 2. You're going to want to put a 2 here. So 2 times 3 gets me my 6 total hydrogens. I'm going to cross this out, give me 6. Now, one thing we have to be careful about is I also just switched my number of nitrogens, because this 2 applies to everything here. So 2 times the 1 nitrogen, that gets me 2 total nitrogens. Now if you're having a hard time visualizing this, this is how we would have drawn this. It's a particle diagram. Sometimes it's just a little bit more visual this way. 2 total molecules, and each one has NH3. So 2 nitrogens and 6 hydrogens. All right. Oh, hey, wow, I didn't even notice that. We ended up balancing this equation just by accident, right? We were just trying to get the hydrogens to work, and then by chance, the nitrogens also balance themselves for us. That'll happen a lot in this. So there you go. Watch the next video for more examples and for some strategies, because as you balance, there's going to be a couple things just to be aware of that'll make your lives a lot easier. All right, thanks for watching, and see you next time.